Okay, so this video is about equations of a circle. Actually really easy stuff. It really relates a lot to parabolas. You're going to notice some similarities and some differences. But first of all, the standard form for a circle, standard form for a circle is x subtract h squared plus y subtract k squared equals a radius squared. H and k comes back again. But this time, instead of being the vertex, it is the center of the circle, would be h and k. Notice how the signs say subtraction. Whatever the signs are, they're going to be the opposite in the center. Nice little thing to know. R equals a radius. So to find r, you have to square root r squared to get it. So whatever that number is, the square root of it gives you r, which is the radius. So that's the standard form for a circle. And this is what those things mean. All right, let's go further. All right, so draw the circle given by the equation y subtract 1 squared equals 36 subtract x plus 4 squared. Now, if you remember, in the standard form, the x and y should be on the same side, and just the number should be on the other side. So I'm going to take this and move it over by adding it. All right, these can't add together because one has a y and one has an x, and they're both been squared. So we can rewrite this as x plus 4 squared plus y subtract 1 squared equals to 36, which is great because I can see h and k. So if that's the case, h and k must be -4 and +1. And the radius, square root of 36, is 6. So if I actually graph that, this is what it would look like. I first have to graph x-axis and y-axis. And my center is at -4, 1. Go over 1, 2, 3, 4. Go up 1. This will be my center of that circle. And my radius is 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'm going to go start from this point and go up 6 units. So if this is at 1, I'm going to go up to 7. This is the point. I'm basically north, south, east, and west around that circle. And then if this is at -4, I got to go over here 6. So 6 to the right of that puts me at 2. If this is at 1, going down 6, it put me at -5. So 1, 2, 3, 4, 5. And to the left of 6 from -4 puts me at -10. So 5, 6, 7, 8, 9, 10. All right, so if you connect the dots now, it looks like a square. So you connect them in a circular fashion. So anyone following the work, know you're trying to graph a circle. So this is a circle that has a center at 4, -4, 1, and has a radius of 6 because I made it so that each point is 6 out in all directions from that center. So we've graphed it. That's what the graph looks like. That's how we can draw that circle once I have it in standard form. So that's what we're talking about in this video. I'm going to give you another one. Here's a new example. So let's write the equation for the circle that has its center at the point 4, 3 and a radius of square root of 3. So square root of 2. So let's start off by knowing that the formula for circle is x subtract h squared plus y subtract k squared equals to the radius squared. And plug everything in. Here's h, here's k. So it's going to be x subtract 4 squared plus y subtract 3 squared equals to my radius squared, so it's the square root of 2 squared, which we know is 2. So the answer is x subtract 4 squared plus y subtract 3 squared equals 2. This would be the equation. You should be able to graph it pretty easily. I through square root 2, you can figure out how long that is and graph it. But anyway, that's the equation for that circle given those characteristics. Got it? Okay, let's do another one. All right, so directions asks to write the equation for the circle that is centered at the origin. It's kind of important to know the center is at the origin. So I know my center is at 0, 0. And has a point 5, negative 12 that lies on a circle. All right, so let's think about it this way. Let's first come up with a picture of this. This is my center, which is at the origin. The point that lies on it is 5, negative 12. So let's go over to 5. Let's say this is negative 12. And this is the point that lies on the circle here at 5, negative 12. So it should be a really big circle. So I know my circle is doing something like this. What I do need, though, is my radius. My question right now is, what is the radius? Because I have the center. Like I can write x subtract h squared plus y subtract k squared equals the radius squared. And I can plug in my center. My center is 0, 0, so it's going to be x subtract 0 squared plus y subtract 0 squared equals to the radius, which is unknown. So let's go and figure out what it is. If I know that this point is here, I now have to go over 5 and down 12 to get there. This is where Pythagoras comes in handy once again. If I know that's the case, I know that this length is 5. This length is down 12, so I'm going to call it positive 12 because the length is positive. So the length is 5 and that length is 12. I want to know this radius here, which so happens to be the c value in the Pythagorean theorem. So if that's the case, I could easily say, well, a squared plus b squared equals a c squared. A is 5, b is 12, c is unknown. So we get 25 plus 144 equals a c squared. So 169 equals c squared. And then when you square root 169 and you square root c squared, you get c equals to 13. So this length here is 13. So my radius must be 13. So if I know that, I can plug in 13 for r. And technically, does x subtract 0? This means x. And y subtract nothing leaves you with y. So since there's nothing else in there, I don't need to keep up with those parentheses. I can call this simply x squared plus y squared equals a 169. So I have the equation for that circle. It's x squared plus y squared equals a 169. So there it is. That's how you actually do that one. All right, let's look at a different one. All right, so in this example, actually to write an equation for the line that is tangent to the circle, x squared plus y squared equals 17 at the point 4, 1. So I would actually begin this with a graph. If they said the circle was this, I know my center must be 0, 0. Because you not have anything subtracted there, so my center is at the origin. And then my radius, square root of 17. It's 4 point something. So let's start there. Center 0, 0. And I also know that the point 4, 1 is on the circle. So 1, 2, 3, 4, up 1. So this is the point 4, 1. It actually exists on the circle. So now my circle looks something like this, because it has to go through that point. And I have to find the equations for the line that's tangent to. So if you remember from geometry, tangent lines are the lines that intersect the circle once. It like barely touches the circle. So it must do this. So this must be the line we're looking for. All right, so that is the line that we want to know, and we want to write an equation for it. Some y equals mx plus b equation. All right, so let's think about what we know about geometry. All right, first of all, we learned that that tangent line meets the radius of that circle at a right angle. So essentially, I'm looking for the slope of this line because this is a perpendicular line. I'm going to find a perpendicular slope. It's going to be the opposite reciprocal. Opposite reciprocal slopes. So if I want to find the slope of this line, it's pretty easy. We want rise and run. So what is the rise and run from this point to that one? Well, I ran over 4. I rose 1. So my rise over run for this line is 4 over 1 over 4. So my perpendicular slope, rise and run, is the reciprocal of that. So you got to flip it and change the sign. So the perpendicular slope is -4. That's great. I know my slope. Now if I knew the b value of that line, that'd be awesome. So let's use this formula. This formula is called the point slope formula. Point slope formula. It's an awesome formula because all you need is a point and a slope. You can write the equation for a line. The formula is y subtract y1 equals to m times x subtract x1. So if I want to write the equation for that line, I need an m and I need a y1 and x1. I got a point that's on that line. Here it is. This is my x1, this is my y1. My m was -4 because it's a perpendicular line. So when I plug it all in, it should be y subtract y1, so 1, equals to, my m should be -4 times x subtract x1, which is 4. So it's y subtract 1 equals to -4x plus 16. Your final step in this line is add 1 to both sides. That will leave you with y equals to -4x plus 17. And there it is. That's the equation for the line that is tangent to that circle and passes through that point. I do want to make that 4 look more like a -4. So that's it. Got another one. All right, last example. Write the equation in standard form for a circle. You already know standard form is x subtract h squared plus y subtract k squared equals some radius squared. So basically you want to write binomial squareds here. Binomial squareds come from perfect trinomials. Hence, we're going back to completing the square. So what you want to do is rewrite this so I can actually complete the square. Rewrite this as x squared plus 2x plus some number c, call that c sub 1. And then this y squared is out of order. It comes after the 4, so let's put it first. Y squared plus 4y plus, I'm going to call this one c sub 2, my new c. This 2 over here I don't want, subtract over here. Equals -2. So basically I want to find out what c is so I can make that perfect trinomial. C has to be half of b squared, so it's x squared plus 2x plus half of 2 squared, and then that's going to be y squared plus 4y plus half of 4 squared equals a -2. And these two numbers we just created have to go over there. So that 2 over 2 squared has to go over, and that 4 over 2 squared has to go over there, so my equation is balanced. This gives you x squared plus 2x plus 1 plus y squared plus 4y plus half, that's 2, that's 4, equals a -2 plus 1 plus 4. So that's -1, that's 3. We add all that together. This is a perfect trinomial. This piece factor would be x plus 1 times x plus 1. And this factor would be y plus 2 times y plus 2 equals a 3. So this means it's going to be x plus 1 quantity squared plus y plus 2 quantity squared equals 3. And that's it. If I wanted my center, I can easily see my center. It's at -1, -2. If I wanted my radius, I know it's square root of 3. That's it. That's all I have. Good luck.